Hello, my name is Edward Landy, and this is E and Z configuration with Clomiphene and Tamoxifen. So they're both two drugs. Tamoxifen is used to treat breast cancer, and Clomiphene is used to treat infertility. And today we're going to learn how to classify them as either E or Z configuration. So we first have to look at the alkene double bonds, which are in the middle of the molecule. And then we move on to the substituents, which surround the alkene double bond. And chlorine actually is the highest ranked priority, and this is the first one that goes away from the alkene double bond, so we use that. And then we compare it to the carbon, the atomic weight. So chlorine has a higher atomic weight than the carbon and the ethane and the two benzenes. So then we have to figure out what are the other priorities of ethane. So we move on to the next carbon, and that is still the same as the carbons in the benzene. So we move on to the hydrogen, which is the last atom that can be farthest away from the double bond. And we see that hydrogen has a lower atomic weight, so carbon is going to have a higher priority and give higher priority to the two benzenes on the left side of the screen than to the ethane. So ethane is the lowest ranked substituent. So now we have to look at the other carbons in the benzene rings, and then we realize that, oh, there's an oxygen coming out of the benzene, and there's the benzene on the bottom of the screen has nothing else. So we compare that oxygen to the carbon in the benzene on the bottom of the screen, and we see that oxygen has a higher atomic weight than the carbon. So that means we give the benzene with the oxygen a higher priority than the benzene without the oxygen. So now we have the left and the right sides of the tamoxifen, and we divide it down the center, and then we look at the both benzenes, and just like what we discussed in the last slide, we saw that the benzene that has this extra oxygen and other nitrogens on it is going to have a higher priority on the left side over the benzene. And then on the right side we have benzene and ethane, and as we know, benzene has a higher priority because when we compare the carbon and the benzene from the hydrogen and the ethane, we have higher atomic weight. So now we divide it into top and bottom sides, and because the highest priority of the two sides are on the top side, we see that the configuration is Z configuration because they're both on the top side. And if they're on the bottom, both on the bottom side, then they would still be Z configuration. However, if say the benzene was on the bottom side, then that means the configuration would be E. So now we have our second molecule type, the clomiphene, and we divide it down the center, left and right, and we see that chlorine is going to have a higher priority on the left side over the benzene on the left side. And then we look at the right side, and we see that the benzene has a higher priority over the benzene without the oxygen on the right side. So then we divide into top and right, and we see at top and bottom, and we see that the configuration is still going to be Z. And now moving on to where we have clomiphene and tamoxifen side by side. So we already know that with the highest priority ones highlighted in red, and then clomiphene, which was in the last slide, however, it's in a slightly different mirrored orientation, but it's still going to be in the Z configuration because both of the highest priority substituents on both the left and the right side are both going to be on the top side.